vision for this book was to give students a sense of what chemistry really is. So many books are just a body of knowledge that students can't relate to, and so we wanted to give an idea of how fascinating this subject really is. And to do that, we thought we had to do it with more than just a book. It had to have good electronic resources that integrate beautifully with it. And so the whole thing was a seamless project. In fact, we don't talk about a book, we talk about a project. And the idea was to produce a readable book and then to also have simulations and animations and interactive activities that students could get feedback on. The first thing I'm most proud of in the project is the pedagogy. We're targeting student misconceptions that we know of. We're also using visualization to help students imagine the molecular world and how complicated it is. And also, we put facts and patterns first and then follow that up with explanatory models rather than the other way around, which you find in most books. Another of the important features of our project is OWL. It enables you to get individualization in large classes, which is very hard to get. OWL offers simulations and tutorials, drill and practice questions, but it's really the tracking of student progress which is really valuable when you've got a large number of students and you want to know whether they're keeping up with you. And all of that's done sort of pain-free. And finally, we're most proud of the current topics that we've got all throughout the book. In the case studies, each chapter starts with a case study, and chapter 1 has 2 case studies to give students an idea of what chemistry really is about. So we cover climate change, we cover ocean acidification, all topics that are really highly relevant. What I'd like to show academics are the full range of electronic resources that we have. Not only the electronic resources that come from the electronic book, the e-book, but also OWL as well. OWL is a classroom management system that has a lot of drill and practice questions, good support for students who haven't got a good maths background and a chemistry background, and simulations and tutorials. The other electronic resources that you can access through the e-book involve animations, simulations, and interactive problems as well. Some really interesting problems as well, not just the sort of crank the handle stuff that we see a lot of. Well, I think there are 3 things they'll like or appreciate, and that is the readability of the text. We've tried to write it in a friendly style, and we also paid a lot of attention to language and use of symbolism so we don't create misconceptions. We have handy little summaries, bottom line summaries at the end of each section, and an end of chapter summary, which we think students will appreciate when they're trying to study. We also have a lot of interactive electronic resources that give students feedback on their learning, and they're all looking for that. And then we're also immersing them in the molecular world with the Odyssey software, and that enables them to be creative as well. Who's heard of being creative when they're studying chemistry? And finally, we've got a large variety of problem types, a bit more interesting than the normal sort of, here's a question, what's the answer type of thing. We've got some thinking tasks and spreadsheets where they can analyze to get information. And so we're trying to get that variety in there that students like. I think one way that our book is different from other resources in chemistry is really reflected in the title, Chemistry, Human Activity, Chemical Reactivity. And by human activity, we're saying it's a question of modeling reality. And we do that by showing great applications of chemistry to everyday life through the case studies. One of the major challenges in teaching chemistry is to help students to relate what they see and observe in the laboratory in everyday life, the macro level, and imagine that in their mind's eye at the molecular level, And that's why we use the visualizations, and then to relate all of that to the symbolic level of chemistry and the mathematical level, which is the hardest part of chemistry. We have an enormous range of resources to help students target those three different levels in the form of laboratory videos, molecular visualizations, and plenty of different problems that help them think their way through all of the ideas. Well, the cutting edge of science is at the molecular level. We're able to visualize individual molecules using high-resolution transmission electron microscopy. Computational chemists can model molecules that we can't even make. And together, it enables us to go down to the molecular level and do molecular level architecture to design molecules with unique properties. It's a fascinating time to do chemistry.